so you have an n by 1 board with 2 diagonally opposite corners colored. Okay. I definitely want to draw for this one. Oh, this is also ISL? Seems like a misattribution from Croatia then. Learner, do you know the year? If this is also ISL? Whoa, it me, the DJ Madman. Hey David, welcome to the stream. Good to see you. Yeah, we heard. People were very excited you were coming. Okay, so let's just draw a grid. Turn all cells black. So originally, okay, so actually the first thing that strikes me is that I'm surprised the task is necessarily possible because there's not necessarily, it's not like you can achieve every board configuration. The reason is that you have a set of, 2n moves. Like there's 2n allowed moves. Thank you, the applesauce 23 for the follow. This is not scaled correctly. Oh, alright, so there's 2 unallowed moves, but there are n squared possible states of board. So part of me feels a little uneasy about this already because it's not necessarily possible to achieve every state. And so, you know, the fact that it's 2 opposite corners actually seems quite important. Yeah, I agree. We are definitely going to work with F2. We're definitely working mod 2, and we're going to treat it as adding a bunch of ones. So actually, yeah, forget the shading. I'm just going to write 1. So initially, the outer, there's 2 corners that are labeled 1. The rest are all 0, and you're allowed to add. Yeah, you're allowed to add stuff. Can I hide that cursor? It's actually really distracting. Nope. Oh. Shout out to DJ Mathman from Dotted Calculator. Yeah, I need to do a better job of watching the reward queue. I miss things a lot. Two n possible, 4 to the... It means at most 4 to the n possible configurations achievable. But you will lose a factor of 2 for every like non-trivial relation. For example, if I do all the rows and all the columns, that actually does nothing. So it's actually, there's at least 1 factor of 2 you drop. Thank you to... yeah, thanks to Brian ZJK for the 100-bit cheer. I appreciate it. Yeah, so I think the first thing I want to do is find like any sequence of moves that will get me to this like particular state, because it seems surprising to me that it's always possible. Wait, is it two diagonally opposite corner cells colored black. It's just these two, right? Or sorry, I'm not sure what's been counting. So how is this possible? Oh, all right. Have fun with NT2. See ya. Read the last sentence. Oh, sorry, I misread the problem. Oh my god. Okay. The problem is I want to add some ones so that the task becomes possible. Okay, fine. I thought it was like, at least how many operations do you need to do? Because I thought it was like the number of operations times n or something. Okay, that makes much more sense, because I was like, this doesn't seem like it should be possible. Okay, cool. So, alright, then we have a lower bound. If I color these three guys, then the task becomes possible. And so, is corners enough? I would believe corners, actually. So, if I color the corners black, is there a sequence of moves that gets this set? I want to say... no, but let me give it a shot. So, the nice thing about these F2 addition problems is that the moves are all commutative. So, a series of operations boils down to just a set of which rows or columns I want to pick. The other thing is sufficient because, let me put it back up. So, I had this idea that maybe I just do this. Wait, oh, sorry, you're right, it's not actually sufficient. Well, sorry, I misspoke. Ignore the thing I said earlier. Wait, actually, hang on. 4 corners I think is probably not sufficient. Because let's say without loss of generality, I want to use that one. Then I don't have this one. So you must use this one. So you don't have this one. And then you're definitely going to be unhappy here. If you do 2 edges to corner, so honestly, I think because the rows and columns all commute, I think the fact that it's a row corner versus not a corner is not that important. Like it's sort of just like what's the minimum number of non-trivial ones I can get? Let black equals 0, white equals 1, and use the determinant. Okay, well actually also something just occurred to me, which is that now that I've read the problem, I think I remember something. What's 3VT's idea? Sorry, one moment please. I'm gonna query my database. Why is my Python path not working? Oh. Why does it say string limiter? Does it still say that? Oh shoot, did I forget to... Oh no. I had the wrong category the entire time. I should change the stream name to Oops Otis Abs. Yeah, sorry, I'm not streaming limiter. That was an error. Okay, I have to apologize. My Why? Okay. I thought I fixed this already, but apparently this is just not fixed yet. Okay. Found it. Okay, got it. So, sorry, let me get back to the chat. I was So there's a problem that looks like this, which is that I think it's basically the opposite, the reverse of this problem, where you start with all ones, or actually it's not necessarily all ones. But there's a China problem that's like looks like this. Okay, all right, what am I stream? What's the title called? Oops, Otis apps exist. All right. Oh my god, I can keep up today. Edit stream info. Maybe at some point I should like hire a moderator to help me watch the chat while I'm trying to do that. Otis 6 no, I if you submit Otis 6 cancel at the request, I am rejecting it. Alright, what did I miss? Has anyone seen XOR in Olympiads? Yes. Okay, so that happened. Okay, anyways, where was I? Alright, so I got totally sidetracked. So actually, I want to say that with oh wait, the China problem is different. Sorry, the China problem you pick an entire, you pick a cell and it increments both the row and column. Sorry, that's not right. So we're gonna comment that out. I somehow thought it was the same thing, but okay. I guess I have to actually do the problem now. Wait, okay, I think this is silly. Like, here's the point. So, suppose I toggled some rows and columns, all right? And without loss of generality, I'm going to order it like this. So you toggle the first some rows and the first something columns. Then what happens is that, well, the final shape is very predictable. It looks like, I guess this is a weird example. I didn't mean for it to be symmetric. Here, you end up with, also there's 0 and not 1. So given a set of moves, like for the rows and for the columns, your final state will look something like this. It will be, you know, a rectangle with zeros, and then like another rectangle with zeros, and then some ones. And the question is basically asking like, what's the minimum possible ones you can have? But you can explicitly compute how many there are, because if this one is A, if there's A of these and then B of these, the number of ones is, it's almost asking this. The one little caveat is that there's a requirement that at least 2 of the ones in the problem are oh, shout out to Raymond Fine for getting Elmo bronze. Right. Yeah. Should I pick different letters? I'm gonna use B as the number of non-things here, so it's a little more symmetric. So no, actually, that's what I what? No, that's not what I want. There's one caveat, which is that you can't have all the ones be in the same row or column, and there have to be at least 2. But I think basically the problem is asking this, like if I have A and B between 0 and n, or actually I guess 1 and n minus 1 or whatever, how small can this quantity be? And I guess the answer is like, well, okay, what is it? It's like, so this is A plus n minus 2ab. Okay. So how do I make this small without actually being equal to 0? Can I view the image? Did someone make a attacker? Oh my god. Guys, help me minimize this. Like, I feel like I should just be able to do it, but I don't actually know what the minimum is off my head. I want to say it's at least n minus 2. Although, in that case, A equals B equals 1, so it doesn't work anyways. Well, actually, n squared minus... Don't you get at least 2n minus 2? Actually... If A equals B equals 1, it is 2n minus 2. So, okay. The question is that the true minimum? Like, is it true that there's at least 2n minus 2 unless A and B are like some degenerate cases? I don't know. That's equivalent to A plus B minus 2 times n being at least 2ab minus 2. Yeah, do you guys really want me to do the determinant thing? The determinant thing is like if I take the determinant of this matrix, it's initially 0 and moves to, or the final determinant is 0 and each move does something? I'm not sure. Thanks, and Wendru for the cheer. But regardless, I really should be able to do this calculation down here. I'm just like tired, I think. I might not get to the China TST because I'm already like... okay, 2n minus 2. This is sharp when a equals b equals n as well? No, it's not. That's actually... But it's sharp when it's like both n minus... Ah. This is embarrassing. I should know how to do this. Okay, well, let me troll a little bit. The number of ones is equal to like a, b plus n minus a, n minus b. And by Cauchy-Schwarz, the square of this is less than or equal to a plus n minus a plus b plus n minus b. No, sorry. A squared plus n minus a squared times b squared plus n minus b squared. A and b cannot both be... A, b can't be n or 0 because then you don't... Or I guess they could be. No, actually, a... Okay, but either way, I think this is the right way to think about it. The number of zeros on the board is bounded above by Cauchy-Schwarz. I think that's how you like quote unquote nicely do it bound. And then each of these is maximized when a is actually far from the endpoints. So I think at this point I just kind of have to do some cases and say like if there's a bunch of... If any of the variables are 1 or 0, then... Or sorry, 0 or n, then you should run into problems, I think. Yeah, so... Oops. So 2 cases. Yeah, this will do it. This will do it. So, if 0 or n appears, this case requires at least 2n minus 2 added ones. Well, let me do total ones. I think added ones is not a good metric. Uh, 2n minus 2 ones total. But if otherwise, the optimal case is when, let's say, a is in 1 or n minus 1, and b is in 1 or n minus 1. And I think these cases are basically one of them is... These cases are not too different from each other, I think. But the point is that you only need to check the situation where... Yeah. Yes, so... So I think this gives a final answer of 2n minus 4, is that correct? So like 2n minus 2 total ones. Because at the when you look at the equality case, it's like sorry, not 2n minus 2, 2n minus 3. 2n minus 1 here. So the optimum is to just take like 1 row, 1 column, and then you get like... No. So I'm trolling. It is 2n minus 4. They cancel each other out. 4, 2. And then it's like 1, 1, 1, 0, 1, 1, 1. I think that's optimal. Does rearrangement work? Oh. Yes, rearrangement probably works. I don't know why. I just looked at it as like, how do I do this? And that line greater than, can you multiply by 2 and add minus 1 squared? Probably. My point is like, I feel like this should just not be a particularly hard algebra problem. And Cauchy seemed like sort of the most conceptual way to separate A and B, given the expression that looked like that, but it's not. It doesn't really matter. I did apply Cauchy-Schwarz correctly, right? This is... Other ways to notice that 2 by 2 subgrid should have an even number of ones. Yeah, that sounds about right. Okay, so I think this should work there. So Evan, where have you seen XOR? There's a problem I often use on Otis practice test that has XOR in it. But I probably shouldn't say it here for because I want to use all my Otis practice tests.